How's it going, everyone? Welcome. Euler Gonzalez again. Now, finally, in today's video, let's take a look at the limiting exposure. This is part of the book of You Don't Know JavaScript Yet. And where is it? Is this one? Okay. Um, so yeah, here we are in the chapter 7 of limiting exposure, limiting scope exposure, uh, but it's based on the principle of privilege. It is based on it is based on the principle of least privilege, a security concept that from a high level overview system design, it is involved, or it is for different components in a system. If their share capabilities, if their share minimum capabilities amounts them, right? If one of them misbehave or go rogue, it won't compromise the overall system architecture. Okay, so in this case, we are looking, or Kyle Simpson, the author of this book, is presenting this idea is because in the low level features, which is something that is impact heavily as a developers, it is way much. It is important for us to not expose is the or to avoid overexposing of variables, right? So why is that? Because if you don't do that, so you now have to deal with a new kind of problems here, and that is the um, naming collisions. Okay, especially if you define now variables, uh, or you expose variables with the same name in that particular scope, then you will have some unintended behaviors. And also another issue is that you'll have unintended behavior, especially if you assume in your code that you expect something, but this is especially true for JavaScript. This something doesn't happen too much on TypeScript. So, for example, if you assume that you're going to receive a collection or an array of numbers, and then somehow you now receive an array of booleans or strings, so now it's going to behave in an unexpected way. And the other is the uh, overexpositions of variables leads to this uh, dependency overexposure, or unintended dependency. So for some reason, if you are exposing everything in a particular scope, including private methods, it is quite hard for you to then have to refactor that model or that scope to remove or to hide that uh, um, private variable. You can do by creating is now is or by setting versions of that, right? But the idea here is that only expose the bare minimum that you need to. And this is why we look now at how you can um, follow this principle, right, of the least of principle of least exposure, which say, hey, in the case of let and cons, it is pretty more straightforward. All right, you just only define in that particular scope the variables you need to hold. And for example, is calculating is a difference. All right. The other is now using is a function enclosing, scoping a function, especially with the var and functions declarations, as a way to now wrap this declaration or that variable, all right, and only expose the specific value that you need to, not the entire variable or not the entire data sets. For example, in this case. And the other is the when you need, for example, is this is work for variables, and when it comes for functions, you enclose that into a function, all right? And because that name identifier of the function will be used by the JavaScript engine and attach that, depending on the environment, and may or may not, to attach that variable to the global scope as a variable that you can have access to, whether it's a global in the case of node, or self in the case of the web worker, or the window object in browsers. So it turns out that as we did this, and if for some reason we need redefine that functionality, somehow we want to use that functionality later on, okay, we can use now is and immediately invoke function expressions to do so. So you wrap now all of the functionality into this immediately invoke function expressions and hold that variable, aka you're now is avoiding to use an identifier, which I do think that this is one of the powerful thing of this. You avoid to use now an identifier, right? And of course save now variable's name. So this, but as they mention here, if you for somehow, this is now part of the thing of working with immediately function expressions. If you somehow need to wrap a code around a return and this, a break or continue, an immediately invoke function expression is probably not the best approach. In this case, you might look to create a scope with a block instead of a function. That is quite interesting. And then you look at now scoping with blocks, right? So you should by this point feel fairly comfortable with the merit of creating a scope to limiting identifier exposure. So far we have looked at doing this via function, it as immediately function expression scope, but let's now consider using its let declarations with nested blocks. In general, any curly brace pair with a statement will act as a block, but not necessarily as a scope. And this is exactly the other point. It's like scoping with blocks. We look at scoping with functions and immediately invoke function expressions as a way to now is save us an identifier that is going to be registered at our global, right? If you define that as a global, aka we'll save ourselves now we avoid is the name collision, which is good, great, awesome. And the other is looking now at the block, scoping with block. So one interesting thing of this scoping with block is that anytime that you define is a block, okay, this is not necessarily a scope yet, and it becomes a scope only when a let cons is now defined inside of this. All right. So for example, you define now a scope or you define now a block in a for loop, and then you assign this identifier, you are indicating that this will be now a block scope. And that to me is quite interesting because not all, and this is specifically to JavaScript, not all curly braces will behave as a scope. Only when a let and cons declarations now contain a block scope, now it becomes a scope, a block scope. So not all curly braces paired create blocks and thus are eligible to become scopes. So object literal use curly braces paired to delimit their key value list, but such object values are not scope. Classes use the curly braces around its body definition, but this is not a block or scope. Exactly. So a function uses a curly braces around its body, but this is not technically a block. It is a statement for the function body, however, is a function scope. And in the switch statements, they don't define a block scope. Other than such non-block examples like this, curly braces can define a block attachment attached to the statement, like an if or for, or stand alone by itself. See the outermost, this one. Curly brace pair in the previous snippet. An explicit block of this sort, it has no declaration, it is not actually an scope, and serves no operational purpose, though it can still be useful as semantic and signal. Explicit standalone blocks have always been valid JavaScript syntax, but since they couldn't be a scope prior to ES6, let and cons, they are quite rare. However, post ES6, they are starting to catch on a little bit. In most languages that support block scoping, an explicit block scope is an extremely common pattern for creating a narrow slice of scope from one of a few variables. So following the principle of least exposure, we should embrace this pattern more widespread in JavaScript as well. Use explicit block scoping to narrow the exposure of identifier to a minimal practical. An explicit block scope can be useful even inside of another block, whether our outer block is a scope or not. So this is a block, but not on a scope. Okay, this is both a block and explicit code because when you're starting to use now a let here, right? And then you have now recovery from something. Here's the curly braces pair inside of the if statement is an even smaller inexplicit block scope for message. Since that variable is not needed for the entire if block, most developer will just block scope message to the if block. Exactly. And move on. And to be fair, when there is only a few lines to consider, it is a toss-up judgment call. But as the code grows, these overexposures issues become more pronounced. So it doesn't matter enough to add the extra curly brace pair and indentation level. I think you should follow the principle of least exposure and always within reasons. Define the smallest block for each variable. And so I recommend, define the smallest block for each variable. And so I recommend using the extra explicit block scope as shown. Recall the discussion of the TDC error from uninitialized variables in the chapter 3, which is the temporal dead zone, which is what happened when certain declarations like let and cons, when you define this definition past appear the first statement in that moment, okay, before that. So what happened before the declarations? What happened with the reference before the declaration? And this is this temporal dead zone. You can have access to that variables, but the variables now are hosted, but you can reference that in that particular block. So my suggestion, there was there was to minimize the risk of TDC by putting those declarations at the top of that block scope. If you find some yourself placing a let declaration in the middle of a scope, first things, oh no, TDC alert like this. So for example, in this case, this is the way of how now is describing is how you define is next month and year. The current month, if you want to do some computation here, you want to extract some computation here. And then you update now is the identifiers out of the block scope, okay? And then once this block scope is being evaluated, so it will now move to the next one and say, hey, next month is equal to 1. Well, the year is this one. And then return this as expected. But again, this is because the point is to define only the variables when you want to hold some operations at that particular scope. At that particular scope. And then you somehow now update those identifiers from the outer scope. And here we look at this particular even more substantial example. So for example, sort names by length. And this is a very interesting exercise. So here what it's doing is that, hey, let me take a list. Let me think these collections as a bucket where each one of those buckets has a number from 0 to n, all right? And what I'm gonna do is that if at that position of the length of that name I don't have any, all right? Well, I'm going to create now is a collection. It's a list in that bucket, all right? So when I do that, then I'm going to now append to that position all of this name that has that particular length, right? So here, once you finish to do that, all right, you will have is now a collections with, you will have all of these buckets with all of these different names already sorted, right? And if you want to now say surname by length, so once you know all of this, all what you have to do is to say, hey, let me now is sort each one of those buckets, or exactly. So in each one of those buckets, let me now sort this alphabetically, all right? In the bucket 1. If I have now a name with only 1, if I have a name with the number 3, with length 3. If I have a name with length 10, you know, in once I have all of these buckets already sorted, so what I want to do is to, once I have this bucket at this position sorted, all right, then I want to now is grab all of this already sorted and append that into another bucket. In other words, into a new collection, into a result here. Go to the next collections of buckets and sort it, and then put it all of this here, right? But reuse is what you have now previously. Reuse is what you have now previously here. And this is quite interesting here. Sort name by length. Here is now using as a for to say, hey, we're creating is a block scope here, all right, that it will only live here, first name and names here. All right, we are updating is the bucket initially with all of this length. All right, and then a block to narrow the scope as it is, which is this. Which say, hey, I block to narrow the scope. So hey, let me now get the sorted names, aka is I'm going to sort each one of those buckets. All right, and whatever I have, append the sorted names to a running list. Exactly. So and then once I already have all of that sorted, I'm gonna append that to the ladder. So in other words, here is going to reshuffle what we have on the sort name plus the bucket. And I want to do now for each one of those buckets that I have here. There are 6 identifier declares across 5 different scope. The identifier, exactly, so we have names, buckets, first name, 3, 4, and 5. We have 5 identifiers defining different scopes here. There are 6 identifiers. 6 identifiers. One, including sort name. They are 1, 2, 3, 4, 5, 6 identifiers in different scope, across 5 different scope. So you have now the function scope, you have now the parameter scope, you have also the for scope, 3. You also have now a block scope, and you also have now another for scope here across 5 different scope. Could all these variables have existed in the single outer global scope? Yes. Technically, since they're all uniquely named and thus have no name collisions, but this will be a really poor co-organization, and I will likely to lead to both confusion and future bugs. We split them out into each inner nested scope as appropriate. So we split them into each inner nested scope as appropriate. Each variable is defined in the innermost scope possible for the program to operate as desired. Sort name could have been defined in the top level function scope, but is only needed for the second half of these functions. And to avoid overexposing that variable in a high level scope, we again following the principle of least exposure and block scope in the inner explicit block scope. But it all is when you're going to use that. So the thing here is that when you are going to use that variable, and depend when you want to expose that variable, it that makes sense to go with. Okay. Okay. All right. Okay. So This is it, right? And then we look now at var and let. And next, let's talk about the declaration of var buckets. And that variable is used across the entire function except the final return statement. Any variable that is needed across all or even most of a function should be declared so that such usage is obvious. The declaration var buckets. That variable is used across the entire function except the final return statement. Any variable that is needed across all or even most of a function should be declared so that such usage is obvious. The parameter name is in use across the whole function, but there is no way limit the scope of parameter, so it behaves as a function-wide declaration regardless. So why did we use var instead of let to declare the bucket variables? There are both semantic and technical reasons to choose var here. Stylistically, var has always, from the early days of JavaScript, signaling variable that belongs to a whole function, as we observe in the lexical scope chapter 1. So var attached to the nearest enclosing function scope no matter where it appears. That's not even if var appear inside of a block. Exactly. So in this case, if we use var, we're saying, hey, this is now function scope, not block scope. Even though var is inside of a block, in the declaration is function scope to div, not block scope. While you can declare var inside of a block and still have it be function scope, I will recommend against this approach except in a few specific cases discussed in Appendix A. Otherwise, var should be reserved for use in the top level of a function. Why not use let in the same location? Because var is visually distinct from let and therefore signals clearly this variable is function scope. Using let in the top level scope, especially if it's not in the first few lines of functions, and when all the other declaration in block use let, does not visually draw attention to the difference with the function scope declaration. In other words, I feel var better communicating function scope than let does, and let both communicates and achieve block scoping where var is insufficient. As long as your programs are going to need both function scope and block scope variables, the most sensible and readable approach is to use both var and let together, each for their own best purpose. There are other semantics and operational reasons to choose var or let in different scenarios. We'll explore the case for var and let in more detail in Appendix A. My recommendation to use both var and let is clearly controversial and contradicts the majority. Is far more common to hear assertions like var is broken, let's fix it, and never use var, let's replace it. Those opinions are valid, but they're merely opinions. Just like mine, var is not factually broken or deprecated. It has worked since the early JavaScript and it will continue to work as long as the JavaScript is around. Where to let? My advice to reserve var for mostly only top level function scope means that most other declarations should use let, but you may still wondering how to decide where each declaration in your programs belong to a block. Paul already guides you on those decisions, but let's make sure the explicit state. The way to decide is not based on which keyword you want to use. The way to decide is to ask, what is the most minimal scope exposure that is sufficient for this variable? Once that is answered, what is the most minimal scope exposure that is sufficient for this variable. You will know if a variable belongs in a block scope or in a function scope. If you decide initially that a variable should be on block's scope and later realize it needs to be elevated to be function scope, then that dictates a change not only in the location of the variable's declaration, but also the declarator keyword use. The decision-making progress really should process like that. It is a declaration belongs in a block scope. If a declaration belongs in a block scope, use let. If it belongs to a function scope, use var. Again, just my opinion. But another way of sort of visualize the decision making is to consider the pre-ES version of your programs. For example, let's recall the diff again, like this, right? In this version of this, temp is clearly declared in the function scope. It is the appropriate message temporal. It will argue, or I will argue, no, temporal is only needed for those few statements if it's not needed for the return statement. It should therefore be a block scope. That's interesting. That's interesting. If that particularly variable is not, in the case of function, is not needed in the return keyword, so it wouldn't make sense to define this as it is. Prior to EX6, we didn't have the let, so we couldn't actually block scope it. But we could do the next best thing in signaling our intent. To say, hey, temporal is still function scope, but the placement here semantically signals blocking scope, as it is. But again, it doesn't behave that way. Var, let, and cons doesn't behave that way. And placing the var declaration for temporal inside the if statement signals to the reader of the code that temporals belong to that block. Even though JavaScript doesn't enforce that scoping, the semantic signal still has benefit for the reader of the code. Following this perspective, you can find any var that is inside of a block of this sort and switch it to let to inform the semantic signal already being sent. So instead of doing, and this is why a lot of these interview questions, so on and so forth, actually asking for this kind of silly question, which is the most common of all of this. So if you, for example, define is this, right? Likes the, come on. If you, for example, define now a for loop as it is with var, right? And then once that is done, I would like to now have access to the var I, okay? It will print that out as 5, my friend. You know what I mean? Because it's the behavior, because of the behavior of var. Because var, and this is quite interesting to understand at least how to work with variables, values, and recognize that working with variables is one of the most important things that you do in any programming language, whether it's a scripting or a compile, as well as the scope, okay, and how the scope works, especially here in JavaScript. And this is now a silly question that I can see that in a lot of job interview. And when they say things like this and say set timeout, as you can see here, right? And then you say no, diggy, I do ones too. Well, just console.log is the value of I, right? After 1 second, right? And if you do ones too now, print this after each iteration. You can say, hey, let me grab this and then do this. And you might expect this to work as expected. 3, 4, 5, you know? But it tells you, that it now give it to you all of this in 5, right? And it is because when this block is evaluated, var is not block scope. Var is function scope. And if doesn't have any function wrapper, it'll be now a global scope. It will be attached to the global scope. In other words, you can now, at least in the browser environments, you can have access to that variables I, all right, and get the value of 5. You know what I mean? So it means that the scope here is not working as expected. So, in other words, what's happening here is that because this code is being evaluated first, all right, and because this code is evaluated first, and it is evaluated synchronously, is not block scope, aka is gonna run the first time is this, schedule this to the callback queue, the next time this, and the next time 3, and the next time 4, and the next time 5. And remember, here all of this I is a reference to these variables. It's not creating a new variable with with that value here. It's just passing now is a reference. So if we do wants to fix this behavior, right? Well, thanks to EXIS, is now give us this identifier that say any time that you find this keyword, all right, it will now be block scope, aka so on each one of these iterations you are going to pass now a reference, but this reference will be now updated with the proper value. So in the first iteration it will be 0. All right, you are now schedule this task to the callback queue with this reference 0 at that moment, and in the next iterations, because this identifier is scoping, or because this identifier tells that this, because this keyword tells that this identifier name is block scope, all right, so now the next variable that you're creating here is with the value of 1, and this is what you're going to pass as a reference to this function here. And as you can see here, this is actually creating is a close over, okay, because now you can also do is with function and it will work as expected, you know, 0, 1, 2, 3, 4, 5, because it started from 0, that's right, we didn't include 5. And also you can do this in a regressive way, right? You can say, hey, I do want to start from 5, all right, and then I want to reach to 0 if less than 0. Check for that, and this is what I do after through I evaluate this code, right? So now it will start from 5. If I want to continue, exactly, I wanna do the stop condition will be if I is greater than exactly the I is greater than 0, so it's going to now show this, but it's not showing in the wait a single moment. Oh, if let is I do think it's because this is interesting. What's happening here? Here I'm telling you, hey, let's going to start with 5. I do want to stop when I is greater than 0. Okay. Similar for this. If I is okay, I want to start from 0 and I want to stop if I is equal or greater to 5, right? So what I'm doing here is to say, hey, I want to stop is I is equal or less than 0. So since here is starting with I, diggy diggy. So I do want to stop this if the I is, so if I, exactly, if I is greater than 0, okay, well, go on, let's going to decrement this, right? So let's hit set timeout that I'm passing here. It will now print is that number at 5, and then decrement that, which to me is quite interesting. Let me refresh this a little bit. Okay. So somehow it's saying that by the time that I'm passing this reference here, it's showing the value of 1, which to me is mind blowing. It's showing the value of 1 is showing the value of 1. Look at this. So what it's doing here is this. So it evaluates okay. Okay. No, it's doing as expected. But it is okay. It is now it's working as expected. Just the condition that I'm passing here does not. Okay? So what happened is that the first iteration, this is 5, alright? That I do want to do that at 5 seconds, right? But, okay, then I need to somehow is subtract that amount, all right? So initially this will be now as, so if I do want to now trigger 5 first, what I have to do is to say, hey, I do fire this initially, all right? I do fire this initially to say, in this case, I minus 5, all right? and then that amount will be multiplied by that, right? So what am I doing here? I'm saying is, and I do want is to make in this way, right? Because what I'm doing here is to say, hey, this is the maximum element that we have, right? And we're gonna start from there. So I do want to schedule a task that is going to start from that position, that's going to start from that position, and then, which will be 0, it means I do want to trigger, I don't want to schedule this, so I do want to schedule is this task that's going to be executed right away with the last value in the last position. On the next iteration, then I say, hey, now I do want to schedule this another task, but with the difference, or in the second last position, right? And multiply by 10, which means give you the difference here. So what I'm doing here is just to give me is now the difference on each one of these elements, right? Starting from the end, and any time that you give it to me that difference, I do want to schedule now is a task, right? Until it reach that to that condition which is here. And now, because that's right, it's this one. And now it will okay, and there you got it. Oh, it's because also the stop condition here is that I do want to do this. If I is greater than 0, go ahead. Exactly. 1, and then stop that, right? So all of this, what I'm guarantee is that every so what I'm guarantee here is that at every time that I'm at every iteration, I'm just guarantee that I get the difference of that, right? And any time that I get that difference, I'm going to schedule a task to the callback here, and do the same again, 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 until now that number that I'm using to decrease across the collection reach to a particular point, which is 1 in this case. This is why now include is 0. So this is something to describe is what is going on here, and if you're able to describe this particular process, you're ready to go for the next interview questions. Absolutely. But now we understand is one and for all is about this scope, about the nature of this, about the var and the let, and why they behave like so. For example, with this example, another example that was historically based on var, but which should now pretty much always use let, is in the for loop, like this. No matter where such loop is defined, the I should basically always be used only inside of the loop, which is in which case Paul dictate it should be declared with the let and instead. And this is a very clear definition of why exposure variables in the scope, the principle of least exposure, it makes a lot of sense. It makes a ton of sense. Hmm. Mm-mm-mm-mm-mm. It makes a ton of sense. It makes a ton of sense. It makes a ton of sense. Mhm. Okay. All right. Okay. Exactly. The loop stopped early. Almost the only case where switching a var to let in this way will break your code if you were rely on accessing the loop iterator outside after the loop, such as this. This usage pattern is not terribly uncommon, but most feel it's made like poor code structure. A preference approach is to use another outer scope variable for that purpose, like this. And then you assign that, and then you do this. So what's the catch? So far we have asserted that var and parameters are function scope and let's encounter signal block scope declarations. And there is one little exception to call out, the catch clause. Since the introduction of try and catch back in EX6 1999, the catch clause has used an additional little known block scoping declaration capability. Let's get into this. Try doesn't exist and catch it creates now a reference error. Doesn't exist is not defined message printed from the code as sections. Let only here true and var outer variable here. True. Outer variable here is true. Mm-hmm. Console.log error is reference an error. The error variable declared by the catch clause is block scope to that block. This catch clause block can hold other block scope declaration via let, but a var declaration inside of this block still attached to the outer function global scope. EX 2019 recently, at the time of his writing, changed catch clause so their declaration is optional. In the declaration is omitted, the catch block is no longer is no longer by default a scope. It is still a block throw. Though, so if you need to reason the condition that an exceptional occur, so you can gracefully recover, but you don't care about the error value itself, you can omit the catch declaration here, like so. Try do option 1 and do option 2 instead. Catch declaration omitted. This is a small but delightful simplification of the syntax. For a fairly common use case, you may also be slightly more performant in removing an unnecessary scope. So what happens is with the try and catch error you are creating now is a block scope, right? Especially here with the error. You are creating is a scope here. But sometimes you don't need to do that, right? But if something went wrong with these async operations, you can do something else. Functions declaration in block. We have seen now the declaration using let or const are block scope, and var declarations are function scope. So what about function declarations that appear directly inside blocks? As a feature, this is called the function declaration in blocks. We have seen now the declaration using let and const and block scope, and var declarations are function scope. So what about function declaration that appear inside a block? As a feature, this is called what appeared to that, bro? Okay. So we typically think that the function declarations like that they are equivalent to var declarations. Really? So they are function scope like var is, no, and yes. I know that's confusing, and let's dig in. So if you do, for example, is this, all right? What do you expect for this program to do? These three reasonable outcomes. If this is false, okay. First thing first, this is an statement. So it's going to evaluate this statement. But if we saw that JavaScript is a compile, and it's like a compile language, we have now a compile phase and then a runtime phase, right? It doesn't behave like a strict language. It means that anytime that it finds any functions declaration, all right, it will host to that, aka making the function ask executable, all right, because first is based on that logic. It's based on that logic. And say type error ask is not a function. So it means that only at top level block. So if for some reason you say this, it will of course runs it. So if you now wrap functionalities here, and this is why my bending. If you now wrap this is according to the developer tools. Okay, the ask call might fall with a reference error exception because the ask identifier is a block scope to the if blocks, exactly, because the ask identifier is a block scope and thus isn't available to the outer global scope. The ask might fall with a type error exception because the ask identifier exists but it is undefined. I do think it's the second one, which is exactly what happened here. So it hosts this function, but it doesn't have okay. So it hosts that function, exactly. It hosts that function, which makes a lot of sense of our intuition. Okay, so the JavaScript is going to, even though it somewhat behaves like a JavaScript environment, it look now at the declaration, okay, and it's going to scope that, right? So any var and functions declaration here, all right, it will now uh, associate it is variable to an identifier here. Okay, so the declaration of this is going to be now at that. So in other words, when you the compiler, what it does is to identify is this identifier match is going to register these identifiers based on functions in var. So it's going to register this identifier in the scope, right, via the scope manager. But by the time that this is executed with the runtime, or by the runtime, by the engine, it say, hey, this is full and I'm gonna get in here. And one is ask this is say, yes, I do have that ask, but this is not the value that I'm expecting here. So that is interesting. That is interesting. Holy moly, bro. Especially when you define functions like this. Here is the confusing part. Depending on which JavaScript environment you try that code snippet, you may get different results. This is one of those few crazy areas where existing legacy behavior betrays a predictable outcome. The JavaScript specifications say that function declarations inside of blocks are block scope. So the answer should be 1, like this. So you get now a reference error to match that definition. However, most browser-based JavaScript engine, including V8, which comes from Chrome but is also using Node, will behave as 2, meaning the identifier is a scope outside the if block, but the function value is not automatically initialized. Exactly, it's not hoisted, so it remains undefined. Why are browser JavaScript engines allowed to behave contrary to the specification? Because these engines already have certain behaviors around function in block, functions declarations in block, ES6 introduce blocks out. Because this these engines already has certain behaviors around FBI before ES6 introduced block scoping, and there was a concern that changing to adhere to the specification might break some existing websites. JavaScript code as such, and a section was made in Appendix B of this of the JavaScript specification, which allows certain deviations for browser JavaScript engines only. You wouldn't typically categorize Node as a browser JavaScript environment since it's usually run on the server, but Node.js V8 engine is shared with Chrome and Edge browsers. Since V8 is first a browser JavaScript engine, it adopts the Appendix B exceptions, which then means that the browser exceptions are extended to Node. One of the most common use cases for placing a function declaration in a block is to conditionally define a function one way or another, like in an if and else statement, depending on some environment state. For example, here is this, so the type of array is an array is different from define. It means that you can return that. Otherwise is this, so this behaves not like a block statement, or this, if that works. All right, if that is undefined, so let me now is create under the prototype to string call a to say equal to object array here. In other words, it's stringify this. Mm-hmm. Return, okay. Okay, so what you're doing here is to let me now take a look at the prototype to string, all right, which is doing the coercion, all right, this primitive. And I'm gonna call with that object that I'm receiving here, right? And if that actually match is this, it means that it is an array. It is tempting to structure code this way for performance reason, since the type of array.isArray check is only performed once, as opposed to defining just once isArray or putting the if statement inside it. Didn't check will then run unnecessary on every call. In addition to the rest of the FIB deviations, another problem with conditional definition of function, it is harder to debug such a problem if you end up with a bug in the isArray function, and you will first have to figuring out which isArray implementation is actually running. Okay. Sometimes the bug is that the wrong one was applied because the condition check was incorrect. If you define multiple versions of a function, the program is always harder to reason about and maintain. In addition to previous snippets, several of the other function in block corner cases are lurking. Such behavior in various browsers and non-browser JavaScript environments, JavaScript engines that aren't browser-based, will likely vary. For example, like this. If this is true, or if this is, or when evaluated is this. Okay. So if this is true and this is true, and then it's going to now define here this. It's going to execute this every time, and it's creating now in each block is a function call, or it is an identifier ask, and then you say, hey, which ask it will going to run, despite that this is call, right? This is interesting because again, we think, this is how I think the code it will execute. First this statement, then this statement, and then this statement, and then go on to the next statement. So anytime that is identified as a function, it's first going to look at the function statement here, right? So this will be now hosted at the top of this code. And then it's going to evaluate the code, which is this, with this statement. And then you say, hey, no, it's this one. So for example, let's check our let's check this one. So I don't want to do this. So what I'm expecting is to be called is, or what about me, right? Or what about me? Why is this? Well, because again, the same logic of now how the code is being processed and analyzed in JavaScript like a compiler. So it had first a compile version, okay, a compile phase, where any time that it evaluates the functions or var is going to be now it is identifiers attached to the scope, all right, and hosted, all right. So this is the first thing that is going to evaluate. Hey, the first thing it's going to evaluate is functions and var declarations here, and then now host that, right? And any declaration in itself, right? So it means that in this case, it has now the function, so it now register this identifier and host it with this value, right? So put it at the top, and then it's going to evaluate the code. This is the execution code, the execution phase. So this is true and say, hey, well, now that function s is now contains this, right? So it's going to like stepping over, okay, of this identifier with the same name with this value. Then it's going to evaluate the next statement, and it's going to identify is this functions declarations is going to now stepping over the previous ask, but and now we initialize with this new value, and then it's going to now call for ask. Hey, this is the scope manager. Hey, JavaScript engine, I have now, or this is, hey, scope manager, this is the JavaScript engine. I have now an ask identifier here. Do you have that? Yes, I do. So now I'm going to execute that. If that is a function, all right, then I'm going to do that. Which is exactly what happened here if you have now. So for example is this wild weird cases here that it show here. In this program, it's going to evaluate first declarations, functions, and var. You're gonna hoist that, and then it's going to now execute the code, and that match the intuition. Recall that function hosting as described in when can I use a variables in chapter 5 suggests that the final ask in this snippet with wait maybe as message will host above to call to ask. Since it is the last function declaration of the name should win, right? No. It is not my intention to document all the weird corner cases, nor to try to explain why each of them behave in a certain way. That information is, in my opinion, arcane legacy trivia. My real concern with function immediately functions in block, function declaration in block, is what advice can I give to ensure your code behaves predictably in all circumstances. As far as I'm concerned, the only practical answer to avoid the functions declarations in block is to simply avoid function declaration entirely. In other words, never place a function declaration directly inside any block. I always place function declaration anywhere in the top level scope of a function or in the global scope. So for the earlier if else example, my suggestion is to avoid conditions defined in function here and wrap them into a function. Yes, it is maybe slightly less performant, but it's still better overall approach as it is. If that performance hit becomes a critical path issue of your application, I suggest to consider this approach. Using now is a function expression hidden to hold that as a variable, and then now ask for that. It's like overriding that set of instruction. It is important to notice that here I am placing a function expressions, not a declarations, inside the if statement. That's perfectly fine and valid for function expression to appear inside of block. Exactly, so what you're doing is that I define the previous behavior here, and if for some reason now I'm going to override that behavior here. Our discussion about function in block is about avoiding function declarations in block. Even if you test your program and it works correctly, the small benefit you may derive from using styling your code is far outweighed by the potential risks in the future for confusion by other developers or variance in how your code runs in other JavaScript environments. Function in blocks or function declaration in block is not worth it and should be avoided. The point of lexical scope rules in a programming language is so we can appropriately organize our program's variables, both for operational as well as semantic code communication purpose. Hmm. And one of the most important organization technique is to ensure that no variable is overexposed to unnecessary scope. Hopefully, you appreciate block scoping much more than deeply than before. Yes, you're right. So that'll be all for this video. Take care. Bye bye.